Hey guys, welcome to a video of Miss Sims teaching you math with a cat looking at you to start off with. So here we go. In terms of calculus today, just a couple of things I want to say. First and foremost, I put up notes from chapter 5 that were all kind of the 5-2 lesson that really were all the kind of important things out of 5-2. So please take a look at that. But one of the biggest things I really need you to understand is about integrals. And one of the things I need you to understand it's in the notes is that if I'm doing the integral, and let's say I have a curve that goes like this, okay, and maybe I want to integrate from A to B. So you'll notice that this area is under the x-axis. And so one of the things in the notes it tells you is that this will be negative area because it is below the x-axis. That is probably one of the biggest concepts that you need to understand. And then the other concept, which I'm going to do just here on another page, talks about how we're going to write the limit as n approaches infinity of the sum and then of all this stuff, that is now going to be written with sigma. And instead of delta x, we'll use dx. And that's kind of how we change over. So the question the other day about writing the big doofusy E, it's kind of hard to write. In calculus, we write the sum with what it looks like a kind of funny little s, which represents me summing up all those tiny triangles. And I'm doing it as I go to infinity, which means I'm putting in tiny rectangles, which means I'm putting in as many as I possibly can, which essentially is going to fill all the space under the curve. So it actually starts kind of easy today. Basically, we're still not having to do any of the antiderivative rules. It really is just getting used to doing some area based on some geometry shapes that we should know and love already. So the first two problems I've assigned to you is really getting used to you writing this with the summation. Okay, so instead of summation, we'll use the notation for integral. Basically, what it comes down to here is the ck is really going to just be your variable x, and your delta x is what we're going to write as dx. So I'm going to pull all of this off, this limit, and I'm going to write it with the capital looking, SE looking thing here. I'll put my equation in here, which will be 4, the square root of 4 minus, and then that will become x squared, and then dx. All right, now these will be the endpoints to my integral. So I always go low to high. So that is how we're going to write that as an integral. All right, so I'm looking for the integral from 0 to 1 of the square root of the quantity 4 minus x squared dx. So those should be pretty easy. It's really just kind of pulling off the c and ck and making it x. Delta x becomes dx. These become your a and your b endpoints. Again, look in your notes where you see the a and the b, and we talk about the parts of the integral. And then this limit with the sum, so the limit as n goes to infinity of this sum to infinity becomes the symbol for the integral. Okay, so moving on, I've got 3 different problems I've just kind of pulled off of those that you're doing just to show you how really you're going to do these problems today using area formulas. Okay, so I'm going to start with this first one right here, and I'm just going to kind of do like a rough sketch. And so hopefully we know that that would just be a horizontal line that went through negative 20. So I'm going to come down here, and I'm just going to draw a line through negative 20. All right, and we're trying to figure out the integral from 3 to 7. So again, if you imagine kind of filling that area in, you'll notice that we just create a rectangle, right? And so in the rectangle, we have a length here of 4, and we have a height of negative 20. So this integral will end up being 4 times negative 20, which is 80. Anytime we have constants, we're going to end up with a shape that is a rectangle. And so it's going to be the difference in the two, how far apart these are, and then what times the outcome. Okay, so that one's pretty easy. Now, the second one I chose is because I need you to understand that this is half a circle. And you want to get used to seeing that so that when you see it in your work, you're like, oh, that's just a formula for half a circle. Because imagine that was y equals all of that. And then I would undo the square root by squaring, so I'd have y squared equals that, and then bring the x over. So it's just a circle, but it's only the top half of the circle. So as I go to sketch this, I know that it would have a radius of 4. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. And so again, it's just the top half of my circle. Right? So they've got me doing the integral from -4 to 0. So that really is only 1/4 of a circle. Okay, so since again it's about areas, I can think in terms of area. I want to do 1/4 of pi radius squared. So in this problem, I would say 1/4 pi, the radius would be 4 squared. So this 4 and one of those 4's would go away, and I'd be left with 4 pi. So this integral is simply equal to 4 pi. All right. Now, our last one's a little different. Okay, they gave me some kind of random endpoints, but who cares? They're just numbers on the curve is all I think about. So first thing I'm going to do is just maybe start sketching. And I'm sketching the line x, and I'm putting in values for a, and I'm putting in the value of square root 3a. So if I think about putting in a, I would get out a. So get a point right there. And if I put in square root 3a, I'd get out square root 3a. So this would be the curve. And so now, as I try to figure out its area, I can look and see what shape I've created. Hopefully we all kind of see that here. That is definitely a trapezoid. I have a trapezoid in which I have a base that goes from a to 3a. I have a height of a and a height of square root 3a. So my area would be 1/2 my height, base 1a plus base 2 square root 3a. Now, how far apart are these two units? That's a good question. So how many units is it to go from 1a to square root 3a? Well, again, think about distance. That would be the square root of 3a minus 1a, right? So I can put that in right here. Actually, I didn't leave myself much room there. 1/2, and the distance between them would be the square root of 3a minus 1a. And this distance right here was 1a plus square root 3a, like that. So we can start thinking about just maybe factoring out, oops, where'd it go? Just kidding. Factor out an a. So what I'm going to write this as is 1/2. I'll factor out an a, and that will leave me square root 3 minus 1. I'll factor out the a. That will leave me 1 plus square root 3. So I have 1/2 a squared, square root 3 minus 1, 1 plus square root 3. Think about foiling. Hopefully, I'm kind of hoping you notice that those are definitely conjugates, but let's say that we didn't. So we would FOIL it out. We would do square root 3, right? Then I would get square root 3 times square root 3 would be 3. Then I would do, I did outsides. I'd do insides, -1. I'd do last, negative root 3, like that. So those would cancel. I now have 1/2 a squared, and then 3 minus 1 is 2. So the 1/2 and the 2 cancel, and I'm just left with an area of a squared. All right. Now, I'm not going to tell you that is the only way to do this problem, because while I see a trapezoid, I could have maybe broken it into a rectangle and a triangle and just added up the two areas. So it is open to interpretation when it comes to what geometric shape do you want to use. I hope that will help you get through your assignments. I expect you to work together as a class, and good luck and have a good day. And wait a minute, before we leave, why don't you look at the cat one more time? It's happy, it's purring.